Graph Theory Class 9 Video 2. In this video we're going to continue talking about special graphs. In particular we're going to talk about trees. So let's begin with the definition. So before I continue, I want to emphasize that this is a very important definition. The notion of a tree comes up a lot in graph theory. It's one of the most important types of graph. Okay? So let's begin with the definition. So a tree is a connected graph with no cyclic subgraphs. So it's connected, which is like a technicality definition. So it means the graph is in one piece. The most important part of it is that there is no cyclic subgraphs. Okay. So if you recall, cyclic graphs are like C3 looks like this, C4 looks like this, C5 looks like this. And the idea of a tree is you can't find any of these graphs hidden inside a tree. They just don't, you won't find them anywhere inside a tree. So let's just do some examples. Part of the reason it's called a tree is it supposedly looks a bit like a tree. Sometimes trees look a bit like a tree, like the real world definition of a tree. Okay, so for example, this here is a perfectly pretty tree. Okay, and it looks a bit like a tree, I guess. There's like a stump and then branches, and they branch out to leaves at the end or whatever. So this is a tree. The important part is there's none of these cyclic graphs hidden inside it. It's impossible to do a loop, to do a circuit inside a tree without repeating an edge. Right? On these graphs over here, you can do a loop without repeating edges. But on a tree, if you want to get back to where you start, you have to repeat these edges. And that's what makes a tree a tree. Okay? But not every tree looks like a tree. So this is also a tree. Right? This is a perfectly good tree. And this is a perfectly good tree as well. These are all trees. Okay? So the next definition is probably not going to come up again in this course, but I really enjoy this definition, and it sort of just makes me smile every time I see it. So a forest is a collection of trees. A forest is a collection of trees. So for example, if I draw something like this, this is a forest. It's just two trees standing next to each other. That's a forest. Okay? Back to more important things. So this definition is actually important. A leaf is a vertex of degree 1. Okay? So a leaf is any vertex that has degree 1. So if we do some examples, okay, I can draw something like this. Okay, and I could just ask you how many leaves. Does it have? Okay, so you just need to count how many vertices of degree 1 there are. And this bit might be a source of like a common mistake some people make, because this sort of looks like a real world tree. So you might think these are the leaves. Okay, but this down here is also a vertex of degree 1, so it's also a leaf. Even though if you were considering the analogy to the real world, this is like the stump of the tree. In terms of graph theory, you still count it as a leaf. Okay, so this particular tree right here has 1, 2, 3, 4, 5. It has 5 leaves. Okay, let's do another example. This tree right here, how many leaves does this have? It's once you know the definition, it's a relatively simple question, right? A leaf is just a vertex with degree 1. And we spoke about what degree means ages ago. So this is degree 1 and this is degree 1. If I was really to work this all out, I could label them all like this. So these two have degree 1, so this has 2 leaves like that. Okay? So one important thing to note now is that the notion of a leaf makes sense even if you're not talking about a tree. Even if the graph G is not a tree, right? Leaf just means degree 1. That's all it means, okay? So it's common to talk about leaves even when the graph is not a tree. So let's do an example. If I look at this graph here, well, this graph, it's obviously not a tree because it has a cycle. This pink bit is equal to this, which is C3. So this is not a tree. But I can still count the number of leaves. I mean, this is degree 3, 3, 3, 1, 1, 1. So that means that it has 1, 2, 3. But it has 3 leaves. Okay? It still makes sense to say that it has 3 leaves even though it's not a tree. It still makes sense in the world of graph theory to say this. Okay? So this is trees. That's the end of this example, and that's the end of this video.